we go. Alrighty, one more time. I appreciate everybody's time, and to join this demo session, I set 30 minutes, but I can target running up to 1 hour just in case we have questions and your questions. So I can address it in middle of the demo session. You can just turn on the mic, or you can just leave in the chat. Just in case I didn't pay close attention to that, you can just turn on your mic anytime. And of course, I'm going to leave the time after the demo. You can ask questions as well. All right, so what is this is about? This is a course I offer annually for people who are going to take AP Physics in your coming semester. And also for people who might also take physics honors, but really want to have a preview of the program. And with that, I show 10 topics you can see here. So which is about the topics for AP Physics 1, to be honest. But you know that the main chunk behind it is biomechanics. That's why if you look at topics 1 to topic 7, it's biomechanics. And for topic 8 to 10, for AP Physics 1 this year and the year before, they actually do not include it for given reasons. So, so one of the driver behind this program or class is to help students to smoothly transition to AP Physics 1 in terms of a level that you can well, follow your school program, or the best could be you at least to be solid at a certain level of AP Physics 1 topic. But the emphasis of this class is trying to look at the fundamentals behind those topics. So we will not lean much towards such as problem solving for AP Physics 1 level, which is not the focus. Again, the focus is to lay solid on the fundamentals behind the topics and also help for the transition into AP Physics 1. I guess for AP Physics 1 versus AP Physics 2, I'm not sure how many people for next semester are taking AP Physics 2. For AP Physics 2, which also build upon AP Physics 1 topics, especially for mechanics. So topic 1 to topic 7, those topics are very important and also very universal type of topics, which are going to help you for your future physics subjects as well. All right. Before I introduce myself briefly, I think that would be the small part. For the demo tonight, like I said, people need to know how the class is delivered. And also best can also know what is coverage. So that's why they kind of drive me for the following 30, maybe 40 minutes. I really want to comb through each topic. But doing that, number one, so people can understand what is delivery. Number two is I use the word fundamental, but it's a very generic, right? Everybody can see fundamental, but I have several delivery. I want to highlight here that I do want students can derive formula behind the topics. I'm going to show that. It's not like you are handed over F equals ma and you use it, but more like student understand how you get theirs. So this is just one example of lay solid into fundamental. And second is I also want to further group the theorem a little bit more, because I'm not a big fan of you kind of have cheat sheets and there's a bunch of theorems. I do want you to make a story, understand in a high level as well. I also have an example to show that point as well. So with that being said, I think that's pretty fair for the agenda. And before we do that, again, so in case people join late, we're going to have 30, 40 minutes running through those topics in kind of a high level to show the delivery, and also show the contents as well. All right. And if you have difficulty in case, or you feel like it's too easy, this is not indicative of how exactly the level of breadth the actual 10 session class gonna be. But like I said, one more time, it's delivery. And also you can have a sketch idea of the contents. That's all about. All right. Any points people have a question, please turn on your mic and let me know. All right, anytime. And also I have a Q&A session after this. We can have a discussion there as well. All right, hopefully that's a fair. So let's get started. I think, first of all, I need to introduce myself. Specifically for STEM training, I'm in this, it's not industry, in this field for 5 years. I'm an engineer at the daytime, but I'm a fully dedicated to STEM training in my, the time outside the daytime. So these recent years, I focused a lot into computer science, use code, and also physics. So these two subjects have kind of focused a lot this recent years. I also offer EMC, 8, 10 as well, but really depends on the pool for my students. So for physics subjects, I offer physics honors, AP Physics 1, 2, and C. So pretty much this is kind of annually events for this session. I think we better using data to show that. So that's kind of brief version by myself. So I really want to quickly get into the second agenda, which is let's have a demo. All right. Before we do that, any question? I guess that's no. Okay. Meanwhile, let me double check the chat box because sometimes I forget to look at there. I guess chat box is all right. All right. Let's get started. Topics 1 is about vector. This is like 101. So talking about the vector is because you need to understand for physics variables, there's a scalar, there's a vector, right? And there's scalar means there's only quantity driven. And if it is a vector, that means you also include the direction information into it. So for a vector session, which is pretty much a very, how to say, really boot camp chapter, we're gonna talk about how would you gonna deal with, for example, two vectors. First of all, how you gonna represent vectors, right? And represent a vector in terms of, for example, xi plus yj. And of course, you need to understand why we want to do that. The reason why we want to do that is because they're going to help us to deal with, for example, two vectors add up, or two vectors want to find a difference, subtraction. Right? So for vector sessions are really going to help us in later chapters. For example, when you do force analysis, right? Or you try to find the net force, but you have different forces pointing at different directions. How are you going to deal with that? Because they are vectors. And so that pretty much first chapter, topic 1, is to learn how to represent vector and how to add two vector together, either in geometry way, parallelogram, or you can do that in algebra way. So those are kind of bridging. So we need to understand why. So you need to, then you can appreciate how we're going to do that. So that's pretty much about the vector. And then for topic 2, kinematics. One more thing I do want to add in here. In general, for my class, I do appreciate a very interactive environment, but I guess today there could be parents there, and also not yet commitment being really, finalized. So I just, mostly this demo's on my end. But in our actual sessions, I normally what I did is kind of, round robin way or random way. I just pick up people. But for some subjects, people also gonna volunteer him or herself. That's the best I want to have. So, okay. Topic 2, kinematics. For this one, let me just be a little organized, shall we? So vector. For kinematics, which is in high level, you want to describe a moving objects. Remember, I use the word describe. So describe, for example, you want to describe to your friends, I saw something in terms of kinematic language, that is where it is, what is the velocity, and what is acceleration. So these three variables are in the realm of kinematics. How you're going to describe a moving objects. And underneath that, um, there are sets of formulas you need to deliver. But I'm not a really big fan of, so you actually there are 5 formulas, and go ahead and using it, right? So S equals V0, T half AT squared, that kind of stuff. Since this is demo, we don't really have to deep dive into, but I just want to show you my philosophy and the principle basically we're gonna deliver. What I really want to people to, instead of just using that formulas, it's gonna be best to understand how we get theirs. So we need to derive the formulas. And also we need to understand the precondition and when we're gonna using that formulas. And also, pretty much for kinematics, these topics, you are expected to see some questions is about interpret the diagram or plot as well. So they're pretty much very common questions behind the kinematics. And the last one, I guess, is a little basic applications. That is, which formula you're gonna choose for problem solving. And for some questions, when you get there, you understand. Never you're gonna expect question just pinpoint kinematics and using a formula and resolve it. But more instead, it's just one small step. You're gonna resolve it. But that's fine. We're gonna get there. So, and also basic applications. Right. One more time, I want to focus. I guess people are going to have a different understanding, but from my understanding, for physics subject in general, it's a very super important to understand the theorem crystal clearly. But how would you define that crystal clearly? I think one variable, to my understanding, is how you understand the formula, because the formula behind it is literally self-descriptive. So that's why I'm not a big fan of students just remember the formula and go ahead using it, but for instead try to associate. How to associate? Why don't we derive it? So you're gonna keep saying, in an actual session, we are not show formula, we derive formula. So they're gonna help you for long run because people know that people figure things quickly. And 2, it makes sense to build up step by step. So we're also gonna want to build up the formula as well, right? So kinematics, like I said, is to describe a moving objects. And then we are moving on to dynamics. So dynamics is pretty much you're gonna answer a question from your friends. You're just saying to your friend, hey, I saw something, in SVA, your friend's gonna asking you is, okay, why? What is driver? That's pretty much a dynamics. Dynamic is to uncover what is a force. Because a force, we all have the force. May the force be there. Because of force, they're gonna drive the moving. You're gonna see the trajectory, right? And so that pretty much is dynamics. And actually, before I dig a little bit more, I forget one thing. I apologize. There's another thing is for kinematics, and this is also consistent when we're talking about dynamic as well. is about a 2D. Kinematics, which is a 1D versus 2D. And for 2D, most regular questions start with kinematics is about moving objects along a line, right? So you can go right, you can go left, and there's a curve figured out. And then you're gonna see two-dimensional and a very classic, that is you wanna hit the ship because they're parrot, and what would be the angle so that you can have the longest range, right? Typical 2D. So I don't know why I accent just changing that way. Apologize about that. For the 2D, the keyword is decouple. You can decouple 2D problem into 1D. So that's also a very interesting part behind the kinematics. We also want to dig around and go back to dynamics. Like I said, this is for trying to figure out what will be the force. What's going on? What will be the force behind the moving? So we're going to start talking different forces. There's several forces we really want to expand a little bit. One of force is tension, friction. I guess I'll go into too detail now. I just want to show the kind of folders behind each topics. So we're going to talk different forces. But the way I talk in forces, I don't just want to show you, hey, guess what? This is strain. You know what? What's inside tension? That's not fine, right? I really want to fit in fitting this topic into a kind of a set or model. So we could also have application on that as well. For example, when we have weight, because that's also kind of force, we're going to have, for example, apparent weight and absolute weight. Absolute weight. And the best model, not the best, one of model we can talk about this weight is the elevator, right? Just for example, we want to talk about elevator model, for example, a person standing on the weight and the weight lands on the ground of the elevator. So what would be the absolute weight? What would be the apparent weight? And what would those change if the elevator accelerates upward or downwards? So this is a very nice example to show we want to kind of embed it into an example or a model. So that would be better to dive in. So talking about the forces, then we want to understand why we want to talk about different forces is because Newton's law, right? 1, 2, 3. F equals ma, which is the second law. Sorry, I have one people joining, admit. Only we know, here's is very simple formula, but I just want to use in this example, instead of just people grab F equals ma and figure out everything you want to figure out, just treat the formula as a self-descriptive, understand the physical meaning behind it. This is a perfect example to show all the kinematics you see here, A, acceleration, behind the driver is a force. And that's why, you see the chapter after talking kinematics, we want to talk about dynamics because we want to know why force, right? And also starting here's, we also have several models we want to cover as well, which is also associated with the kinematics, which is a circular motion. Circular motion is a model you can simply treat as a objects just have a circle track and that could moving at uniform or constant speed or non-constant speed. We don't need a deep dive. Again, this is demo, but for circular motion, it's a very interesting area, especially for non-constant speed. Because behind it, we also want to talk centripetal force and understand at what scenario centripetal force is the net force, at what scenario which is not. So we're going to also cover that as well. There's other forces going to be included, for example, friction. We also need to understand why maximum static friction is greater than the kinetic friction, just as example in a detail level, all right? But again, dynamics is chapters we need to get down to the force level. And you also gonna appreciate why we need to learn vectors, because you need to figure out the net force. All right. Any questions so far? All right. If no questions, I want to jump a little bit. I would talk topic 4, but instead I want to talk about topic 5, because I want to show one of what I just mentioned earlier regarding I want a student just transition from chapter to chapter, not just step change, just go to a new realm, but they are actually well connected. So this is a good example. When we talk about momentum, so let me just talk a little high level about momentum. On question level, momentum offer us another set of equation to help us to resolve variables in kinematics and also in dynamics. That will be the high level. And this is just scratch the surface. But if you dig a little bit deep to look at momentum, like I said, folks, if you are lost, it's totally okay. Just feel the delivery. All right, just feel my voice. We are building up in our session later. But again, momentum is actually coming from Newton's second law, F equals ma. So let me quickly show you that, just as example, right? I love example. So Newton's second law, F equals ma. And we know that for acceleration, what's the definition? That's a delta V over delta T. And then let's move this delta T to the left-hand side. We're going to have force times the delta T equals m times the delta V. And that's it. That is the introduction of momentum. We are pretty much down here on the second high level. You see, F times delta T, that's a people name it as what, folks? As a J, which is impulse. And m times delta V, which is m times Vf minus Vi. So people name mass times a V as what? Momentum. You see, this variable actually is a human stuff. It's actually coming from Newton's second law, right? That's number 1. And then number 2, we also appreciate the theorem, so-called momentum to become conservative. There you go. So if impulse, which is net force times delta T, if these folks are 0 or next to 0, then you know what? In that system, the momentum is conservative. There you go. So this is just one example. I want students to get there in fundamental level. All right. One more time, we will not just go ahead and shoot the formula and solve question, which is not fundamental actually. All right. So with that, we understand what this variable are, what are those variables, and also appreciate a little bit more about the theorem, right? And for momentum parts, also a very classic question that would be collision, right? Elastic, inelastic. So we're gonna talk there. We're gonna cover. Let's talk detail later in the session as well. But just understand the momentum chapters is coming from the Newton's second law. All right. Then let's go back to topic 4, work, energy, and power. This is a very interesting parts. Again, why we need to learn work, why we need to learn energy, what is high level? Well, this on question level, I pretty much repeat that again one more time. it offers you another set of equation to resolve the inner variables. How handy is that? And but it look at all these moving objects by different eye or by different angle in terms of work, in terms of energy. Another way you understand the work and energy, that is, just treat the work is kind of a vehicle. You can think about the whole world. It's kind of have a boundary there, and within it, there's different types of energy, right? Thermal energy, kinetic energy, chemical energy, energy from bonds, and kind of energy, all right? But who changed them, right? I mean, you could have some energy from kinetic, you can have some energy from potential, and blah, blah, blah. Well, how are those energy distributed from different kinds or different types? Well, that's a work. The work is just a vehicle to transfer energy from one type to the other, all right? Then if you think a little carefully about what I just said, transfer from one type to the other, this is like object oriented, all right? Transfer to whom? So that's why for this chapter, I remember at the beginning, I said the second in terms of fundamental level, I really want to group theorem instead of distribute. You have cheat sheets, some kinds. Is for specific for this topic, I wanted people to have a kind of a concept that is when every time you have a question, you want to resolve it in terms of work energy and understand the boundary. Or in other words, think about there's a box and the box should including what objects. That really depends on questions. We don't really need to expand here, but just want to show you that the way we attack this area, right? So that would be the high level behind the work energy, right? I guess I want to deep dive a little bit more. Oh, wow, time fast, 7:29. So just briefly. So every year I have students kind of confused about if you already have some fundamentals, you might be familiar with this. That is, there's one theorem said, you know what? The work from the net force is equal to the change of kinetic energy. Everybody just familiar with that? And I don't know which book you're using, but right underneath that, there's another theorem and talking about conservative force, non-conservative force, for example, friction is non-conservative force, and blah, blah, blah. There's another theorem that is, in order to have kinetic energy to be conservative, you have to making sure that in your system, there's no non-conservative force, which confuses a lot of people. So my way to attack here is, again, we are one of making this theorem a little bit more consistent. That is, in my word, we're going to have a red box. In that red box, once you know what you want to throw in the red box, that pretty much define what energy you're going to talk about. For example, if this is there's any friction related, you're going to have thermal energies, you're going to talk about in your red box. If you just talk about a single objects in your red box, you never want to talk potential energy. I just use another example in detail level. Again, so decide what's your put in there. They're going to decide, okay, what energy, what type of energy you're going to talk about. And with that being decided, you can move ahead to the left side to talk about, okay, what kind of work you're going to talk about. A lot of interesting stuff there. So we're going to expand more. Work energy, folks, right? So next one is my perfect rotation motion. So rotation motion, let me just talk a high level. From topic 1 to topic 5, we pretty much talk about translational motion. All right, if you're not familiar with that, just don't worry, just we're gonna get there. And translation motion, rotation motion are two different kind of oscillated rotation motion. For any moving objects, you can always isolate it into translation part and also rotation part. That make a perfect sense that we're starting with the translation and then move on with the rotation, and then we're gonna have some questions combining both. For translational motion, I one more thing, folks. All the content I'm talking here are just kind of flavor, oriented. You just have a flavor. There's a lot of stuff I cannot cram into here. For example, COM, center of mass. If you talk about translation of motion, basically everything you included in your system, let's treat as a single point. That point is called center of mass. Of course, you need to know how to find it. But then for rotation motion, we most of time talking a single object. That's in your book word is a rigid body. So all the formula and theorem we talk in kinematics, dynamics, momentum, work energy, power. There's a set of formula and a theorem in rotation. So when we get to topic 6, basically we're going to have a side-by-side table. Normally I did that every year. But also I want to do specifically after we finish the rotation motion, we're going to have a table. So you can compare, right? Topic 7, circular motion, gravitation. I already talked a little piece about circular motion, but here's we're gonna also talk about this in more general ways because there's also gravitation topic as well. So it's more like add up to the topics into dynamics and also into kinematics for topic 7. But again, principle wise, gonna be consistent as we deliver. All right, like I said, topic 1 to topic 7 are the topics I want students spend most time with me on those topics because they are super important. Gonna help you a lot in your later journey for physics subjects, either ST2 physics if you decide later on, or if you want to take AP Physics 1, mechanics are most important, period, right? And topic 8, 9, 10, I also want to include in our session, but I might want to just a little bit, really depends on our progress, right? Like I said, 1 to 7 are the focus. But student can, for this year, I mean, the year before, we know what happened because of that. The agenda for physics exam are just covering from 1 to 7, but that not necessarily means this going to be wrong as a long term. So people should have basic idea about what is electric force, field, potential, DC circuit, mechanical wave, and the sound. I mean, it's still fair, right? Those are topics also important. When you get there, maybe it's recovered. It's going to be the full 10 chapters exam. So those 3 topics, excuse me, we also cover in our session as well. But high level, right? Electrical force, field potential, to be honest, this is just literally another force. So that's why for some questions, basically just add a new force. Let's name it electrical force. That's it. You're gonna understand that basic what the force is coming from. So which is also in our session as well. But for fields and potential, these 2 are relatively new stuff. So these 2 we are also gonna cover as well, making sure people understand the difference. What are fields? What are potentials? Topics 9, DC circuit. This is the most interesting part if you really deep dive into, if you dive into the physics subjects. This is like if you are hacking people, right? High level. So DC circuit is most want to address a circuit, right? It's not the kind of circuits we expect when you only have a 1 battery, you have a resistor, and then you have a switch. Now switch on, switch off, and calculate some boring stuff. But mostly interesting as you're going to have a multiple batteries, and the battery could have different directions, aligned parallel or serials. And then you're going to have a lot of branches. So this is like a hiking, right? My word. So a lot of interesting stuff here. is you gonna address what are the currents and in terms of volume and also direction for each branch. So pretty much it's including the DC circuit in higher level, what type of question you want to resolve, right? So awesome. Topics 10, mechanical wave and sound. This is finishing up a little bit about mechanical waves. That is, you need to know how to represent a moving wave in terms of its y versus a t versus x versus phase. So that will be part of it. And for the sound, this is just a little, I'll have, oscillated areas. Also, I put in here as well. So like I said, this 30 minutes, think about it, just have a, idea, a little impression about how session should be delivered, a little bit about my principle in physics subjects, which is hopefully people can have idea. Like I said, I see people joining a little late. So again, sessions in actual session, we should be interactive. Of course, if you really do not want to be interactive, we could let me know. But I rather prefer, since we're going to deliver this over the Zoom, it's better to make it interactive, right? So that's also the bar of value for other subjects as well. So hopefully for this year, we also is on it as well. All right. Like I said, that will be the 10 session schedule, 10 topics, which is equivalent to 20 hours. If there's no surprise, I think we're gonna kick it off next Saturday, 7 p.m. We're gonna get started. Since your summer starts, what's the best thing to spend in summer? Physics as one part of it, hopefully. All right. So with that being said, I think I should, this is already 40 minutes. I commit about 30 minutes, but I think we better have some talks. Question here is, will the session be 7 or 8? 7. So we're gonna start at 7 p.m.
Why do you pick Saturday instead of other days? Weekdays?
Saturday, yeah, that's based on the students' availability and my availability, because I don't have summer. So and also think about Sunday, a little cranky, so that's why Saturday. Yes, we're gonna have a recording. If by any chance you cannot attend it, let me know. I'm gonna share the recording.
Will you do homework?
Yes, we're gonna have homework. Homework gonna be important part. Yes.
About how long it takes?
The homework at the starting, they're including choice questions and also FRQ. I will target is average 1 hour to finish it. Depends on topics. At the starting, when we build up vector kinematics, could be, and this is nothing non-respect on the subject's entertaining level. So, but gradually when we build up more, you're gonna expect questions kind of combining different aspects. For example, translational and a rotational combined. There's also type of question as well. And also I'm gonna explain the question as well. Is this a preliminary AP Physics 1 course, or does it cover AP Physics 1 completely? This will cover all the fundamentals behind AP Physics 1 as well. If you look at the 10 topics, there's 10 topics also identical as you see for AP Physics 1 topic. So okay, I think this question is good. Let me wrap it up with another question: how to be excellent in AP Physics 1. So one area is about fundamental parts. So this class handles all the fundamental parts behind it, and which also going to serve for students ready to take AP Physics 1 class as well for next semester. PT time, Pacific, yes. This started on Saturday. Saturday, May 29. I'm sorry. We're gonna start after next week. Let me double check my calendar. I thought next week
No,
is,
should be the June 5th. So
yes, that's right.
where our summer
Yes,
start. Yeah.
that's right. June 5th. Apologize, folks. June 5th. I thought next week is June. Oh, where am I? June 5th. It's not next week, the week after next week. So because I know by then students can have a good time after school. So we want to catch you a good time. That's one of focus. All right. Any other questions? Every Saturday, yes. Yeah, weekly.
Did you where did you have your high school?
I have my high school in China.
Oh.
I finished my master in Shanghai at Fudan University, and then I took my PhD at Penn State, East Coast. Love snow there, and then I landed a job 9 years ago, Bay Area, and then start my journey here. But in starting 2016, I'm into STEM field training. So it's been 5 years. So this type of session I offer annually. And for some years I offer twice because given situation. All right. Yeah, so that reminds my good time in my high school. Yeah, how many years ago? Yeah. Any other questions? Any questions about the class? About myself? Will you offer an AP Physics 2 later on? I did. Depend on students. AP Physics 2 actually is fun, actually. I mean, if you're really into the physics, I mean, I feel a lot of fun in AP Physics 2, to be honest. Even though for AP Physics 1, it's so hard to get 5. Everybody know that, right? Answer is yes, Caroline. And if you look at the map, oh, sorry, go ahead. I kind of interrupt. Nice people want to speak. Sorry about that. Go ahead. Oh, okay. Um, just if you look at the map here, I'm kind of graph people. I love to show something by diagram. We are kind of from regular to AP Physics 1, but I do have questions that such as if I'm not very solid in regular physics, am I ready to take this class? My answer is yes. Like I said, the focus of the class is about fundamental. I kind of show you what my definition of fundamental already. But answer is yes. So the way we want to get into, the realm of physics, right, depends on, depends on situation, right? What you want to, prepare yourself in a package. So when you enter AP Physics 1, that really opens up AP Physics 2, and then you can decide to take SAT Physics 2, then go there. Or you can continue to challenge AP Physics C as well, but remember that's a calculus, base. For AP Physics 1 and also AP Physics 2 are all, algebra. You don't have to do calculus to master on these topics. And given situations and your resources, you can take F equals MA prep. I also have class for that, which is, kind of define the path as which route you want to go. But you might earlier, our discussion, mechanics folks are very important, and which is likely captured in our session by 7 chapters. to lay the fundamental, hopefully solid. So hopefully they're gonna get started on journey. And this is my WeChat. In case you join the session not from the WeChat group, you could scan this and so we can get connected. Or if you're not WeChat people, this is my email address. Let me send to the chat box. There you go. This is a long name, I know. I had this like 9 years ago. So a lot of zeros. Sorry about that. Okay, so I guess that pretty much is what I want to deliver on my end. I think I still stay here for several more minutes in case you have questions. And if you are committed and want to go ahead with it, and let me know. The tuition is $800 and for 20 hours. And we're gonna start. I think you sent a message. Thank you, Caroline. Appreciate that. I suppose need to send everybody. Okay, so this is my email address. And on top of it, that's my WeChat barcode. Hopefully that's big enough. And our session, we're gonna start as June 4th, which is
5th.
5th. Okay, thank you. 5th. Right, which is Saturday. So Saturday, is that right? Saturday,
yes,
right? June 5th.
Saturday,
Okay.
5th.
Thank you. Appreciate
And
it.
you need to change the time from
Yes,
8
7
to 7 p.m.
Yeah, I very initially I said 8, but people are saying it's too late, so let's change to 7. Okay. All right. I can appreciate your time. Saturday night, you spend 1 hour with me instead of your favorites. I appreciate that. That's kind of commitment. I love it.
Thank you.
Oh, thank you.
Thank you.
Thank you so much. All right.
Okay, thank you.
Appreciate it. Have a good weekend. Hiking
you.
tomorrow. Bye-bye.
Bye.
And anyone need a recording, in case you join late, just let me know. I can share that. All right, so bye-bye.